Here's the basic unit, and if you've seen the Frugal Floater video you'll recognize it as being much the same. This has a small Samsung video on top. The handle's different and so is the gimbal, but this will do to start us off. Now here's a closer look, and we have the slider rail with a quick connect on top. There's a little camera. Now in the Frugal Floater, the two attachments on the macro slider rail were internal fitting caps. These are external. They're not quite as good, but they're adequate. And on the right there is the balance weight that's used to counteract the weight of the camera viewing screen. This is a closer look at the disassembled current gimbal head, and we'll go through each of the pieces bit by bit to try and explain what they are. Before we do that, I'll just throw in another couple of pieces. This is a more complete picture which shows on the lower left and fully left two other devices that were used in earlier experimentation, and then we'll move on to specifics. Look for the pencil, which acts as a pointer, and you'll see a screw which just happens to be a suitable diameter to fit into the universal joint. And on the right again you can see the handle, which is schedule 40 1 inch, and there's a set screw that's put in there. It was drilled and tapped for a 4mm small set screw, and that holds the brass plug which you can see in front of the, above the screw. Now here is the brass plug that was turned down from some brass stock. The outer diameter is 1.040, which gives a snug fit inside the schedule 40, and the hole in the middle takes the screw, which is nominal 3mm, which is that size to fit the bottom of the universal joint. Now just a closer look at the brass plug and the screw. Now the next item was some attempt at controlling panning. Again, it's a piece of brass taken from stock, turned down, slightly knurled on the edge, drilled and tapped to take a set screw, and the internal diameter is to match the lower part of the universal joint, and we'll go into more detail on that shortly. It might be worth mentioning here that although one design was using a bearing, it turns out that the brass plug in the handle and the screw that goes through it and into the UJ actually gives a lot of very friction-free rotation, so the bearing idea was abandoned because it was too sensitive. So anyway, the ring that's pointed to here, the pan ring, will go over the lower part of the UJ and lightly held by the set screw, which gives some control on panning. Moving on up, we're now pointing at the universal joint. Now the UJ was obtained off eBay. I forget the specifications that were listed, but anyway, it's a very nicely made unit. However, the hole at the bottom end has an ID of 3mm and the top end is 1/8, which is slightly odd. I dare say it was made for a model. So the lower 3mm hole accepts the screw that we showed earlier that goes through the brass plug that goes into the handle, and the lower part of the UJ is fitted with the panning disc, shall we say. Now notice at the top, what we have there is a 1/4 by 20 piece of threaded rod, which is turned down to make a spigot of 1/8, Then there's a nut, just a regular nut, and enough 1/4 by 20 to fit into the base of the macro slider. So at the moment things are disassembled, but if you imagine the spigot goes into the universal joint and held by a set screw, and then the 1/4 inch goes into the base of the macro slider. Now just to mention on two other things that were tried earlier and have so far been put to one side. The pencil here is pointing to the bearing assembly that I made to go underneath the macro slider. What we have here is a chunk of scrap that I turned down, and on the left you can see the 1/4 by 20 spigot which goes into the macro slider, and then the larger part is bored out to accept the outer diameter of this small ball race, which is some sort of model ball race which happened to be in a box of bits. That's secured with a set screw, which is actually a little bit on the long side. And then the small piece is again turned down from scrap. The upper part is bored to be an outside diameter to be a close fit to the inside diameter of the ball race. Then there's a slight collar, and then finally the lower part is a spigot which is an 1/8 inch diameter to go into the top of the universal joint. This was tried but actually abandoned because in the end it was so friction free and sensitive that even though the unit was balanced, the rotation was so free as to be a problem. Now this here is a small ball joint assembly which was obtained from eBay. It was actually the smaller of two. I might well have got a larger one usefully, but anyway, this was something for experimentation. Now this is shown with two 5mm Allen head bolts for securing it to the macro slider, and the brass piece is a duplicate slug that I turned down when I made the slug for the other version. So in other words, I made two slugs identical. The only thing is here the inner hole was drilled for tapping, I think it was 4mm, the thread on the ball joint, and the outer diameter of the brass slug, like the other one, is 1.040 to go into the handle. Here's a close-up of the bottom of the macro slider. You'll see the normal 1/4 inch hole in the middle, but either side of that are two holes that I drilled and tapped to take the Allen head bolts for the ball joint. It worked, but the freedom of it was inadequate. It was low friction but not quite low enough. So there, a very quick run through of the current configuration that's being explored. The picture here is showing the complete unit. The weights at the moment are not really quite right. The macro slider has this offset piece with weights on it to compensate for the viewing screen on the camera. That's very critical. But it's also been noticed that the lengths of PVC tube are, while held from a friction point of view in the elbow or elbows and 45 degree, it's far too easily upset, and this is probably going to have to be glued or pinned so that balancing can be done and actually not change. So it's a useful idea, but we're not there yet. Now, just for completeness sake, here's the basic schematic of the handle and gimbal as it is when assembled. Give you some idea. It's not dimensioned, but you can see the brass plug inside the Schedule 4D handle, the brass pan disc, the universal joint, and then on the left the small threaded piece with the 1/8 spigot going into the universal joint, and the nut actually acts as a lock nut. So that's just to give you some idea, although the drawing doesn't reproduce very well. Here's a forward and back test. It's not perfect, it's getting close. Taken with a very poor still camera, so the video quality is terrible, I'm afraid. But it's getting there. Last of all, a little bit of trial run. It's not balanced right, there's a bit of pendulum effect, and the pan is a little bit sensitive. So there's quite a lot more work to be done, but it's an interesting project and we'll hope to make improvements. Thank you for watching.